Hi guys, this is the video for your review, page 620 from your textbook, and I think there will be at least 2, if not 3 videos for this. So I hope this is helpful. So let's start with number 1. Number 1 through 4, we have to find the next 4 terms. In this one, I found the common difference of 12, so I just subtracted the 2 terms. And then the 4 terms that's coming after this is these. So number 1 was just simple arithmetic. Number 2, this one was added 4, and this one is added 8, and then 16. So I feel like these are multiplying. The difference is multiplied by 2. So then the next 4 terms is these. So I'm adding 64, 128, and so forth. Number 3 is actually quite interesting because you're not just looking at the first difference, you're looking at the second differences. So the first difference goes like this, and you might be wondering what is a pattern here. And the pattern is that it's adding by an odd number. So the second difference will be this. So then you add 16, and then you'll be adding 9 in the second difference. So that means that you will be actually adding 25 to get the actual number. So the 4 terms is these 4. Number 4, we can tell this is multiplied. It's common ratio because of the negative and positive number flip-flopping. And the only way to do that is when you're multiplying by a certain number, a negative number, and they are all multiples of 3. So I'm assuming that it's divided by negative 3. Then the next 4 term is these. Alright, number 5 is a word problem, and I actually had a very difficult time understanding this problem, and I think this is how you are doing it. So the first month there is a female and a male rabbit, right? And then the second month they're still by themselves, but then the third month they can't produce. So there is that original, but then they produced 1 female and 1 male offspring. So then 4th month, there is still they can still produce a new pair of rabbits, but then the one that came from the 3rd month can't yet. So then the 5th month, these guys are continuing reproduction, and then now under the blue guys, they're still developing, but then the yellow pair actually can reproduce as well. There. All right. And then the 6th month, the red pair can still reproduce, so there's a new pair right here. The green one can't. There's still, but then the blue pair now can. So there. And then yellow pair can continue as well. And so let me do 2 glitter ones, okay? So the last one is produced by the yellow pair. So together you have 8 pairs, meaning that you will have 16 rabbits total. And if you notice, this is actually, it kind of works like a Fibonacci sequence, even though it's times 2. Because you have female and male, but if you just look at it as a pair, it goes 1 pair, 1 pair, 2 pair, 3 pairs. So it's 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, and 8, and so forth. So it's a Fibonacci sequence in pairs. But to actually find how many rabbits there are, you have to multiply by 2 because each pair has 2 rabbits. 6 through 9 is whether it converges or diverges, right? And so we talked about how converging means that there's no limit, so it goes to infinity or negative infinity, whereas diverging means there is a limit. So this one, you can tell that it continues to grow and there will be no end. So this will be divergent. Let's look at number 7. I'm gonna plug in and figure out a couple of terms here. It's given as a recursive formula. So the other one, the second term is 14 over 3. And then, oh yikes, not so nice number, eh? 14 over 3 minus 1 over 3. So you can tell this number is getting smaller. So 14 over 3 so it's 15, and then 4.6 repeating, 1.2 repeating. And so it is heading toward, it's not going in negative infinity. It has a limit, it kind of curves, and then there is an asymptote there reaching to. So this is converging. Convergent. Let's look at this one. It's 48 divided by 2, and then divided by 2, and divided by 2. So you keep dividing it by 2, and so it will get very close to 0, but it will never become 0, right? So this one is also convergent. It's okay if you don't know what the limit is, as long as you can tell that something is infinitely increasing or decreasing. If it doesn't do that, then it will be most likely converging. And this one you can tell it's diverging because you know the shape of this function. It goes like this, right? And so as n grows, your a n will grow as well. So that diverges. Number 10. Find each sum. So this one, obviously, you will kind of have to do it long way. So I'm gonna plug in 0 first, add 1, add 2 squared, add 3 squared. So you see how it goes, right? 9 squared over 4. So if you do all this in a calculator, you get 285 over 4 as an answer. Number 11, same thing. You plug it in. So we start with negative 5 here. Do you see negative 5 cubed plus 7 plus negative 4 cubed plus 7 all the way to 0 cubed plus 7. And this becomes negative 183. I hope it's okay that I'm not showing you how I'm calculating because I'm assuming you all have a calculator. This one is 2 to the 1 power. So do you see how I'm putting where n is, each number, plus 2 squared minus 4, plus to 6 power minus 4. And that is 102. Last one, 4 times 8 minus 10 plus 4 times 9 minus 10 plus all the way to 4 times 13 minus 10. And that equals to 192. Okay. So some of them, you could have done it as arithmetic, like number 13 is an arithmetic sequence. So you could have used the formula for series to use that, but I have a calculator, so I just got lazy and did it with a calculator. In a charity golf tournament, each of the top 10 finishers wins a donation to the charity of his or her choice. So it says it's an arithmetic sequence. It tells you. And basically the first term is this, second term, and third term. So since it's arithmetic, I need to figure out the difference, and it seems like the difference is negative 250. We need to find the last term, A10, so that we can use the partial sum, which was n over 2, A1 plus A10, right? So A10, we can find it by using the other formula, which goes A1 plus n minus 1 times d. And A1 is 2500 plus 9 times negative 250. So that's 250. So this number is 250. So then we plug it in. So 10 over 2, 2500 plus 250. Alright, so 2,750 times 5. So total amount is 13750. I hope I can finish 15 through 18 before the time ends. It says write an explicit formula and recursive formula for each of the arithmetic sequence. So we know these are all arithmetic. So that means we need to find the common difference. This is -4, so d is -4. So then an, I'm going to write the explicit formula first. Plus n minus 1 times -4. You can simplify it, but I will leave it like that. Recursive formula, guys, very important. A1 must be explicitly given, or else it's considered wrong. Okay, it's incomplete. And an is just a n minus 1 minus 4 because it's just common difference. Let's look at 16. 16, the common difference is 12 plus 12, right? Because it's getting less negative. So the explicit formula is -96 plus n minus 1 times 12. And then recursive would be a1 equal -96. an is a n minus 1 plus 12. I hope this is easy. This is adding 3, so the common difference is that. So 7 plus n minus 1 times 3. Recursive, a1, 7, an is a n minus 1 plus 3. Last one. Common difference here is -2. So then explicit formula will be 32 plus n minus 1 times -2. Or you don't have to write it that way. You can write it as 32 minus 2 times n minus 1. Doesn't really matter. A1 is 32. An is a n minus 1 minus 2. Couple things I want you to be very careful of is recursive formula needs a1. Another thing is make sure that n minus 1 or an is small. The n is smaller and n minus 1 is smaller, so that there's no doubt about that it's the previous term instead of me thinking that it's an minus 1, like an equation, right? All right, so we are going to do 19 in the next video because I'm almost out of time. So stay tuned for part 2.